Hello everybody, and welcome to my presentation for this week's class assignment in Robotics 211 over at the University of Advancing Technology. I am an online student, and for this assignment, I had to make a Blinky toy using AVR Studio or Microchip Studio as it's called now, and putting it on my ATM 328P using AVR Dude. So let's get to the nuts and bolts of this. Obviously, this is my assignment. Here's my credentials right here. So the first thing I do, I have to define the CPU speed. We define it as 60 megahertz or 16 million hertz, which is really, really high. It's way above the human threshold of hearing, which the maximum human threshold of hearing is 20 kilohertz. So yeah, very, very high. Okay, so moving on. I include two header files, AVR input and output, utility delay. One is to be able to use the AVR code. The other one is to be able to make things delay. Something new here that really didn't touch on, but is in this program. There's a function in this program, and it's basically a void function. It's called POV display, and it passes an unsigned integer called 1 byte. And I believe the 8_t means that it is 8 bits, which would make sense because we are using an 8-bit controller, basically. So, moving on, we basically delay 200 milliseconds. And then this function stores an unsigned integer of 8 bits. Obviously, that's an 8-bit. Okay, so in the main function, data direction register D equals, this is hexadecimal for pretty much, we're setting everything to ones in this 8-bit register. So that means we're setting every single register, every pin in this register to an output. 1 is an output, 0 is an input. And in the while loop, we're basically turning these lights on and off using POV display, which POV display is a function, calls port D, which basically turns things on and off. And I apologize, my bird is again acting rambunctious. I really need to move him to a different location because it's distracting, and I apologize for that. But anyway, moving on. So as you can see, we're calling this function, and it is using port D, which is turning these lights on and off. So a 1 is on, a 0 is off in these registers. Oh, here's something that is pretty cool. So when we're reading these registers, so this binary register right here, we go from the most significant bit to the least significant bit. So typically in the English world, we read from left to right. This reads from right to left. So in, say, the Arabic world, where sometimes people read, opposite the way we do. And it's true for this binary thing right here. So instead of 0B and then register 0 all the way to register 7, it goes from register 7 all the way to register 0. So that's how that works. And then we set port D back to 0, delay it 100 milliseconds, and it starts all over again. Okay, so let's build this to make sure it builds, which I know it is. So, toy. I'm sorry, the solution. And the output succeeded. Okay, now here's the thing. So when we go to flash this, okay, and upload this to the microchip, there's something that you have to understand, which I didn't at first, and it caused me a lot of confusion. So I'm hoping that this is going to help a lot of people. Yeah, my bird says so too. It's really acting up. But anyway, we're using register D, okay? And on register D, the Arduino Uno version 3 shares its send and transmit pin with output pin 0 and 1 and register D. So when you go to upload this to your chip, if you have wires plugged in, say you're using 0 and 1, and you have those plugged into your breadboard, or you have them plugged into your transmit and receive, it's not going to work. And what's going to happen is you're going to see two lights, one lit and one dimly lit, and that's for your transmit and receive on your Uno. To get around this, before you flash it, take those wires off. So port 0 and 1 should be off, out of the board, okay? Flash it and then connect those wires and everything's going to run fine. If you try to get around that, it's not going to work. And this is just from hard knock experience, okay? So that's pretty much that. I'm going to show you what the code does now in action. Guys, thank you very much, and I do apologize again for my bird. Guys, have a wonderful day. Okay, everybody, so here we go. This is my completed circuit for the Blinky Toy exercise or assignment over at UAT, Robotics 211. As you can see, it's working pretty good. I think what this does is actually you're supposed to have it on this little thing, and you're supposed to rotate it around, you know, like a propeller, and it's supposed to make an image, but I have it stuck on a breadboard. So the only other alternative was like a Cylon Larson scanner type of thing, and I've already done it a million times, so I decided to go with this. But the code works good. Take a look. Awesome.